Welcome to my YouTube channel. So today we are going to tackle quadratics in Pure 1. So here is the course outline on quadratics, what you must be in position to know at the end of the topic. So here we have, they are saying you must be in position to complete the square. So you should be in position to complete the square and also set the coordinate of the vertex. We should be in position to know what a discriminant is and be able to use it. We should be able to solve quadratic equations and quadratic inequalities. We should be able to solve simultaneous equations where one is linear and another one is quadratic. For example, this is a linear equation and this is a circle. So being able to get the point where they intersect is basically you solving simultaneously, and then also being able to solve equations which are quadratic in some function of x. For example, this very expression that these are, we can term them to be complicated quadratic equations. So without wasting time, let's start. So here, so when you are starting quadratics, so one thing you must know is how to complete the square. So here we have a quadratic expression, and the general form of a quadratic expression is ax squared plus bx plus c. This is the general form of a quadratic expression. The b can be 0, the c can be 0, but for you to know that actually this expression is quadratic, it must have x squared. So here we are asked to express this quadratic equation in the form of that. So it is one way of telling us that we need to complete the square. So when we are completing squares, the first thing is that we make sure the coefficient of x squared is 1 and positive. So you can see that this x squared, its coefficient is positive 1. So that is one of the rules, that you make sure that the coefficient of x squared is positive 1. And then you can go ahead and rewrite this expression, which is x squared minus 4x plus 3. But in between here, I've introduced in a 0. I've introduced in the middle 0. But how is this 0 gotten? You look at the coefficient of x. I'm looking at it as just 4, positive 4. You divide it by 2. So 4 divided by 2, you get 2. That's why I added 2 squared minus 2 squared. So when you add something and subtract it, you end up getting a 0. So you've not changed anything to your equation. If, for example, I had 5 there, I would end up adding 5 out of 2 squared minus 5 out of 2 squared. So you have the coefficient of x and add it squared. Then, and the next step, the first three terms, we need to identify a double bracket that can be expanded to give us what is above there. So and the short way is you can move this x down, then you can move this 2. That's why I add it as 2 squared, not adding it as 4 minus 4. So you add this 2, then this sign in the middle, you put it there, and everything squared. So this bracket here, when you expand it, it will give you the first 3 terms. Then the next terms should be minus 4 plus 3, which gives you negative 1. And this is your final answer. You make sure that the coefficient of x squared is positive 1. The next, you go to the coefficient, you need to add a 0. You go to the coefficient of x, you divide it by 2. So we get 2 for my case. 4 divided by 2, we get 2. So add 2 squared minus 2 squared. Then the third step, you need to form a double bracket that can be expanded to give you the first 3 terms. So you move this x, you move this 2, and then the sign in there, everything squared. When I expand this bracket here, I'll get x squared minus 4x plus 4. Then the remaining 3 terms, you end up adding them up together and getting negative 1. So I've completed the square. So the next thing I need to tell the coordinate of the vertex. So a quadratic equation is either facing up or facing down. So here, because this quadratic equation, the coefficient of x squared was positive, that's why it faces up. So here I need to tell the coordinate of the turning point. The vertex is the turning point. So what you do, equate the bracket to 0. So x minus 2, I end up getting 2. X minus 2 equaling to 0, I end up getting 2. And then this here, the value is the y coordinate. So meaning this is my coordinate of the vertex. So this quadratic graph, you can easily get the coordinate of the vertex. We go to the next example. We are also going to express this quadratic equation in the form of a into x plus b squared plus c. So we need to complete squares. So before you begin completing squares, you're supposed to make sure that the coefficient of x squared is positive 1. So I pull out this 2 from the whole equation. And the moment you pull out, you factorize out the 2. Please try entering it again and see whether you get exactly the equation that was given to you. So the moment you have factorized out the 2, then repeat the same step for what is inside the bracket. Now that the coefficient of x squared is positive 1, I look at the coefficient of x, which is 4, I halve it, which is 2, I add a 0. So the previous steps, you repeat them for this very number for what is inside the bracket. So you have 4, which is 2, you add 2 squared minus 2 squared. So you're basically not changing anything, you're adding in a 0. Then the first 3 terms, so keep on carrying the 2. The first 3 terms, you need to identify the bracket that can be expanded to give you x squared minus 4x plus 4. So the short form is you move this x, and then you move this 2, and then take this sign here and put it in the middle. Everything squared. When you expand this bracket, which is a double bracket, you get x squared minus 4x plus 4. So that's why I add it as 2 squared minus 2 squared, not 4, so that you're able to tell the bracket very fast. And then the remaining 3 terms, you add them up together and you end up having plus 3 out of 2. Then your final answer, these 2, remember we removed it from the whole expression, so it is part of this bracket, so it multiplies it out, and then it is also part of this other term here. And if you have 2 times 3 out of 2, the 2's close out and you end up having 3. So this is how I've expressed my quadratic expression in this form, in the form of a x plus b squared, then plus a c. You can set the a is 2, the b is negative 2, and the c is 3. So if you want to tell the coordinate of the vertex, you remember the coordinate is xy. So to get the x coordinate, you equate what is inside the bracket to be 0. So if I have x minus 2 equaling to 0, I end up having the x as 2, and this other value, you take it to be the y, and your coordinate of the vertex is 2, 3. So that's how we complete the square. So solving quadratic equation, it is the easiest because you can have already met it at IGCS. So when it comes to A level, it shouldn't be something that you should worry about, because in the first place, they will not ask you a plain question that asks you to solve. No, you'll come up with you'll be solving equations, and then you come up with something quadratic and you have to go ahead and solve it, but it can't come as a plain number on its own. So in solving quadratic equation, you must be, first of all, be familiar with solving quadratic equation using a calculator. So when you use your calculator, you end up having x as 5 out of 2 and x as a third. Then to show that you used factors, me I say we work backward. Create a bracket which when equated to 0 gives you 5 out of 2. So if I work it, for example, if I solve and get 5 out of 2 and a third, to get that bracket, cross multiply x times 2, you end up having 2x. Then this 5, take it to the left so that you have 2x minus 5. This 2x minus 5, when you equate it to 0, you basically get 5 out of 2. Never work backward and say x minus 5 out of 2. That is wrong. So you cross multiply. For example, if I have x equaling to 5 out of 2, cross multiply to have that bracket so that I have 2x equaling to 5. Then if I want to have a 0 on the right, I take 5 to the left. So that's why I end up having my bracket as 2x minus 5. So you do the same for also this other one, which is a third, cross multiply, and then take 1 to the left, and then you'll be given a mark for you to show that you used factors. So they basically do not, they don't always dictate on the method to use of solving quadratic equation. So if you get whole numbers or fraction, work backward. You can see that on my number 2, I got, when solved on a calculator, you get x as 2, negative 2 out of 3, and x equal to 5. So to get a bracket, cross multiply. So meaning you skip a space, give your solutions that you've gotten on the calculator, and then work backward. So cross multiply, you get 3x, and then this other 2 which is on the right, when you take it on the left, it becomes a positive. And then this 5 which is positive, when you take it to the left, it becomes negative. So yeah, so you're giving actually the method that you have used. So working backward only works with fractions and whole numbers. So now assume you meet a quadratic equation and you get decimals that can't even be written as fractions. So the best method you should use should be the quadratic formula. So the best method to use is the quadratic formula, and don't stress out, go ahead breaking it down like you do at IGCS. Why? Because Cambridge assumes you already know from O level, you already know how to solve quadratic equation. So it is important that when you get your answers, you're working backward, as in giving your method, you should only substitute in the quadratic formula. So that's all about solving quadratic equations. So then next we need to learn how to sketch a quadratic graph. But before you start sketching a quadratic graph, here are the 4 things you must know. 1, you must know the shape, how your shape is, and telling the shape of a quadratic graph is very easy. You look at the coefficient of x squared. So if the x squared is negative, then it will be a maximum. Then if the x squared, its coefficient is positive, then it will be a minimum. So according to this kind of quadratic equation that we have, the coefficient of x squared is positive, that's why our graph is a minimum. Then next you need to tell the coordinates of the vertex. We tell the coordinate of the vertex by completing squares. So whenever you're completing squares, you make sure the coefficient of x squared is positive 1. So it is already positive 1, so I go ahead, I look at the coefficient of x, which is 3, I half it, I get 3 out of 2. So add 3 out of 2 squared minus 3 out of 2 squared. So you're adding basically nothing. You're not changing meaning to your quadratic equation. And then here, the first three terms, you move this x, you move the 3 out of 2, and then this sign, everything squared. And this one here, work it out all together, and you end up having your final expression as that. So to get the coordinate of the vertex, you equate the bracket to 0, and then take this other remaining number to be the y. So meaning the curve will be turning at 3 out of 2 and negative 25 out of 4. So that is my coordinate of the vertex. Then the y-intercept. So on the y-intercept, on the y-axis, x is equal to 0. So in the quadratic equation that we are given, when you make your x to be 0, or if you substitute your x to be 0, you end up having your y or your fx as negative 4, meaning it will be crossing at the y-axis at 0, negative 4. Then next we need to know the x-intercept. So you need to know that the x-intercept is when your graph crosses the x-axis. Actually, whenever you solve a quadratic equation, those two x's that you get, or the one x that you get, because sometimes it can be repeated, is when your graph crosses the x-axis. So meaning when I get the x-intercept, and we know that on the x-intercept, y is equal to 0. So when you substitute your y to be 0, you can, or your fx to be 0, and it means you're solving your quadratic equation. And we see clearly that when you solve it, you get x as negative 1 and x as 4. So work backward to show the method that you used, and these x's that you're getting is when your graph crosses the x-axis. So we are getting 1 and we are getting negative 1. We know it is crossing the y-axis at 0, negative 4, and the turning point is at 1.5, negative 25 out of 4. So just join them, and that's how we that's how we sketch the quadratic graph. So there are those 4 things you must know. You must know the shape. You must know the coordinate of the vertex, how to get it by completing squares. You must know how to get the y-intercept, and lastly the x-intercept, which is basically gotten by you solving a quadratic equation. So we are going to complicated quadratic equations. So these are you being able to identify equations which are quadratic in some function. So when you look at this kind of equation here, you could choose relating it to 4x squared minus 37x plus 9 equaling to 0. When you relate, you can see that here if we have x, here we have x squared. When we have x squared, here we shall have x to the power of 4. So it is twice. So if this is x, something to be quadratic, then this is twice it, like x times x. And so you see here, if we have x squared, also x power 4 is twice. It is x squared times x squared, which gives you x power 4. So meaning, being able to recognize that it is quadratic, it makes your life easy. So meaning, if I'm to solve this kind of equation, which is 4 x power 4 minus 37 x squared plus 9. I don't want to let the issue here is you being able to identify that actually it is quadratic. Stop wasting time trying to let. So after me knowing that, then I will solve it. And when I solve it, my solutions are actually x squared. You get your calculator and you try to solve it. You make your a to be 4. You make your a to be 4. You make your b to be you make your b to be negative 37, and you make your c to be 9 in your calculator, and then you can solve it. And when you solve it, you end up getting your answer as a quarter and 9. So I'm going to work backward to show the method that I used. And I told you in solving quadratic equation, you can only work backward if you have fractions and whole numbers. So cross multiply and take 1 to the left. Here it is just taking 9 to the left. But remember, I'm told to solve for x, so I now have my solutions as x squared, so I take a root both sides, and I'll end up having my answer as x equaling 2 plus or minus a half. Here, if I do the same, I'll get my x equaling 2 plus or minus 3. So that's how you are supposed to do it. And then when I go to the so this was our first one. So when you go to your second one, you can see that if this is root of x, and remember x is a root of x is basically x power half. But then when you come to x, which is to the power of 1, actually it is x power half twice, because I'm applying numbers of the same base, we maintain the base and add powers. So meaning this root of x is taking the position of x in a quadratic equation, and then this x is taking a position of x squared in the quadratic equation. So it means that since I've been able to recognize that this is actually a quadratic equation, the moment you see root of x and x in one equation, just know that is a quadratic equation. So I am going to rewrite it and say x minus 4 root of x, and then minus 12 is equal to 0. So it means when I solve, my solutions are actually root of x, so root of x, and then also root of x equaling 2. Get your calculator, make your a to be 1, your b to be negative 4, and you'll end up getting your answer as 6 and getting your answer as negative 2. So work backward, we shall have root x, root x minus 6, and then here we shall have root x plus 2. I have not solved, so what I do, I square both sides to get the x. So I end up having x as 36 and x as 4. Yes, when you square both sides. So you should be in position to tell equations which are quadratic in some way. And then when I go to my third equation, I'm seeing 3 power x, then I'm seeing 9 power x. So there is a relationship. So this 9 power x is actually 3x times 3x. So meaning you can set the 3x is taking the position of x in the original quadratic equation, and 9x is taking the position of x squared. So it is important that you know that. So I will have so my third equation, which is 9x minus 28, 3x, then plus 9 is equal to 0. Some people would wish to let, but me, I don't let, because the issue is, are you being able to tell that this is quadratic in some way? So it means that when I am to solve this quadratic equation, the solutions are 3x, 3 to the power x. So when you solve, you end up having a third, making your a to be 3, your b to be negative 28, and your c to be 9. So you end up having your answer as a third and 9. So I work backward, so I'll end up having 3, then 3x, then minus 1, that is one bracket. Then here we shall have 3x minus 9, add another bracket. So I've not solved actually 4, I've not solved 4, I've not solved 4x. So I can write a third with a base of 3, which is 3x, equaling to 3, negative 1. And so since the bases are the same, I equate the powers, and I end up having x as negative 1. Also here, I could express 9 in terms of the 3. So I'll have 3x equaling to 3 squared, and I get my answer as 2. Then lastly, you also being able to note that actually this is also quadratic is a good thing. You being able to note that that is a quadratic equation is a big deal, because you can see clearly that if I have x power 5, then the other one is x power 5 twice, x power 5 times x power 5, which gives me x power 10. So without wasting time, then you can solve it, but your answers will be x power 5, and then also another one will be x power 5. So substitute in your calculator, make a to be 32, and make b to be negative 31, and c to be negative 1. So when you work out that, it will give you the answer. The b, take it to be negative 31, and then, okay, so hold on, the a is 32, the b is 31, and the c is negative 1. So you get your answer as negative 0.3125 in decimals. So if you have a calculator that can change that to fractions, it's better. So it can be written as fractions. So I have negative, so I'm going to write it because the calculator I have sometimes doesn't convert to fractions. And then another one is actually, it is 1. But this one here can also be written as fractions. Yes, it can be written as fractions. So if you have a better calculator, it really makes your life to be, it makes life easy. It makes life to be easy. So it is better you have a good calculator, which makes life easy. So now here you could use quadratic formula if you, because the quadratic formula can be used anywhere. Much as me, I prefer working backward, so you can always use quadratic formula. So you say negative b plus or minus b squared minus 4a and c, and this expression is under root over 2 times a, which is 32. So if you want to get the x, you take the fifth root both sides. Make sure you have a good calculator and can get for you the fifth root. Make sure you have a good calculator that can give you, and then you easily work it out without any troubles. So that is complicated. That work was about complicated quadratic equation, being able to notice that actually this is quadratic with some function of x. Yes, and then you can solve it. And then also at IGCS, you looked at various ways in which we can solve simultaneous equations. So there's graphical, there's substitution, there's elimination if they all have the same, same orders of x and y's and whatever. But here, if you have a quadratic equation like this, where one is linear and another one is quadratic, the best way is we use substitution. We use substitution. We use substitution method to solve quadratic equations where one is linear and another one is quadratic. So here, since they are all equal to y, we equate them without wasting time. Since they are all equal to y, we equate them and you end up having x squared plus x minus 6 equaling to 0. So if that is my quadratic equation, then what am I forming there? I am forming a quadratic equation that I need to solve. So my a is 1 and your b is 1 and your c is negative 6. So when you solve it, you get your first answer as negative 3 and another one is actually 2, x is 2. So you work backward to show the method you use to solve. So when you work backward, that's it. So for every x, you should get a corresponding value of y because we are solving simultaneously. And you need to know that whenever we solve simultaneously, we are getting the coordinate of intersection. Actually, with Cambridge, they will not ask you to solve simultaneously. They will tell you the line y equaling to 6 minus x meets the curve y equaling to x squared. And then you are asked to find the coordinates of intersection. So basically, we solve simultaneously to get the coordinate of, of intersection. So when x is negative 3, come here and substitute. So you end up having your y as 9. And when x is 2, you end up having your y as 4, meaning my coordinate is negative 3, 9, and then 2, 4. So that's how it's done. And then when you're here, you do the same thing. Here y is the subject, so just come and substitute in equation 2 because we see one is linear and another one is quadratic. So the only way you can solve simultaneously is by substitution. So I'm going to substitute wherever I see y. So I'll say this is 8 x squared minus 2x, and the y we see clearly that it is 3x minus 1, then equaling to 4. So we shall have 8x squared minus 6x plus 2x, actually 6x squared plus 2x, then equaling to 4. So I end up having 2x squared plus 2x minus 4 equaling to 0. So I can easily see that actually I can reduce this by dividing by 2. on each term. So still you're forming something quadratic, so you need to know that you need to solve it, and your A is 1, your B is 1, and your C is negative 2. So meaning when you solve it, you get your calculator, you get your answer as -2, and another x is 1. So work backward to show that you have a formula that you use. The moment you leave alone this step of working backward, if you got whole numbers, or of showing that actually you use the quadratic formula, then you lose a mark. So for every x, get the corresponding value of y. So when x is -2, and then I substitute in any of these, that is easy. So when you make your x to be 2, you end up having your answer as 5. And when you make your x to be 1, you end up having your y as 2, meaning my coordinate of intersection is -2, 5, then 1, 2. We solve simultaneously to get the coordinates of intersection, or where the two meet. So be careful when you're solving simultaneously. Be careful on how to make one the subject, and be very careful with make sure your algebra is good so that you don't make any silly mistakes that will cost you a lot of marks. So here we go to solving quadratic inequalities. At IGCS, you've tackled how to solve linear inequalities, and you should remember the rules that when you divide by a negative, the sign changes. Things like that. So here, when it comes to quadratic, and we are solving quadratic inequalities, we are basically interested in regions where our quadratic graph is positive, or where our quadratic graph is negative. So you must be in position to tell that region. When they say greater than 0, we are interested in the region where our quadratic graph is above the x-axis, because from the x-axis upwards, we know that y is positive. So meaning here the critical points, your determining points is that you need to know when your quadratic graph, this is my quadratic graph. And remember, I told you that whenever you solve a quadratic equation, you're getting coordinates where it is crossing the x-axis. So we see clearly that this quadratic graph is crossing at -2 and actually at 7, at 0.7. And we see clearly that this quadratic graph, because the coefficient of x squared is positive, it is a minimum. This is just a simple sketch. So meaning, if I'm to look at this point carefully, or if I'm to, because I am interested, so the x-axis is the line y equaling to 0. So meaning above the x-axis, the graph is positive, and below the x-axis, our graph is negative. So from this point upwards, the graph is positive. From this point upwards, the graph is positive, but between it is negative. But according to my inequality, my quadratic inequality, I am interested in where my quadratic graph is positive. So it is positive when x is less than -2, because from this point, if I was to consider -3, I would find the graph above. If I was to consider -5, so meaning all values of x that are less than -2 would give me the graph when it is above, the x-axis. And here, if this is a line y equaling to 0, then above it is positive, and then below my graph is negative. So I'm interested in where it is positive. So if I'm interested in positive, then these are the answers. when x is less than -2, and when x is greater than 7. So those are your answers. Those are your answers. So you make sure that you're able to solve a quadratic equation and can tell clearly the region where your graph is negative and where your graph is positive. And you can do that by solving. So solve so that you get when it crosses the x-axis, and after that also be able to evaluate, analyze, and know how to state your answers. So if you have greater, we say x is less than the smallest and x is greater than the biggest. So here on our second example, still we are interested now in knowing the region where our graph is negative, because we have less than 0. So what you do the same thing, and then by solving, because you'll get the critical points, and then after that, those critical points, these are the points when our graph crosses the x-axis. So it crosses at -4.5 and 3. That's when our graph crosses the x-axis. Because we have less, it means we are interested in the region where the graph is negative. So that's why we say between -9 out of 2 and 3. Or you can, so the region in between here is when the graph is negative. So when they give you greater, just know we're interested in where it is positive. When they give you less, we are interested in the region where our graph is negative. So you need to be very careful, and the stating of answers really matter a lot. The stating of answers really matter a lot. So you can see where we had greater, I had to say x is less than the smallest and x is greater than the biggest, because we are interested in where our quadratic graph is above. Then when I go to the less, we are interested in where the region. Inequalities, we are basically looking at regions. We're interested in the region where the quadratic graph is negative, and it is negative between -4.5 and 3. Otherwise, thank you for listening and following me. Please subscribe for more content.